Welcome to the first of 4 videos about Chapter 5 from our textbook, The Mathematics of Power. Chapter 5, Section 1, that's this video, Introduction to Weighted Voting. What do they mean by this phrase, the mathematics of power? Well, I think what they mean is the answer to questions like these. How do you divide up the power in a voting situation where some voters have more power than others? For example, what about the board of directors for a large corporation? What if you want the president or the CEO to have more power in the voting? Maybe you want all of the officers to have more power than any non-officer. Also, how do you factor in the power of the shareholders? All right, another situation. What about a different situation where a mayor and several councilmen sit on a city council? What if there's both a mayor and a head councilman? What if the mayor is the head of the council? There are many different setups used in various cities and organizations throughout the United States and around the world. As you will see, if you are not careful, the setup you choose, the setup you pick, can easily give someone either more or less power than you intended. What this chapter is about is the math behind figuring out just how much power do people have. Now, let me talk for a minute about how these videos are going to work, this one and the others. I'm not going to define the terms I use in the video, at least not usually. There are 2 reasons for this. One, it'll shorten the videos, and 2, really the bigger reason, is that I've seen over the years that the internet students, many of them, tend to get themselves in trouble when they don't make a point of really learning the definitions of the various terms and things that they're using. There's a tendency to get so focused on just answering the questions, you don't really learn the words and the ideas that go with them. And what happens then is once you get to a point where you've covered enough material, you get yourself in trouble because things will all run together. So to try to help prevent that, I'm going to ask you to get the definitions first. Now, this is really not as big a deal as it sounds, especially in this book. One of the really nice features of this book, especially this material in Chapter 5 and in Chapter 6, is that the author does a great job of being short and sweet, very much to the point. Chapter 5, Section 1, for example, only has 3 pages, and you'll find all these definitions, I think, if I remember right anyway, on the first page. So to find these terms, pause the video for a minute, go get these definitions. Quota, player, weight, dictator, veto power, coalition, winning coalition. All right, you get those, and then come back and start up again. All right, let's dive right in here. We're going to work through 3 questions here to cover the basics of the material in 5.1. The table below shows the 6 districts in a specific county and their votes in the Board of Supervisors. Suppose the quota was set at 66% or more of the votes. Describe this weighted voting system using the standard notation. This bit right here is the standard notation. Right there. That's the standard notation. So it looks like this. Standard notation looks like this. Q, that stands for quota, colon, and then each of the weights is listed. Right? Like in a system like this, there are 1, 2, 3, 4, 5, 6 players. So there's going to be 6 weights. 1 weight for each player, W1 up through W6, and then close the bracket. So that's the standard notation. And really, the weights are easy. They're usually given to us, like they were in this case. 27, 22, 14, 12, 10, and 4. Now we just have to figure out the quota, right? Well, usually to know the quota, you need to know the total number of votes. So let's go ahead and do that first. The total number of votes, we're just going to add these up. 27 plus 22 plus 14 plus 12 plus 10 plus 4. We'll add all that up, and you're going to find that the total number of votes in this case is 89. And then over here, they tell us they want the quota to be set at 66% or more of the votes. All right, well, 89, right, times 0.66 equals 58.74. All right? Now, the quota, right, so we're talking about votes, so it's always a whole number. So in this case, the next whole number up from 58.74 is 59. And this is our answer to this question. Now, I do want you to notice something here. The quota is not necessary. This time we just rounded, right? 58.74 rounds to 59. It could have come out. What if it had come out 58.2? Okay. Well, the directions say 66% or more. In this case, if it had been 58.2, the quota still would be 59. You wouldn't just round to 58. Because if you're at 58, you wouldn't quite have the 66%, right? You got to make sure you have that percentage. So it's the next, it usually is the next whole number up, in this case 59. All right, 2 more questions. So, and actually each of these questions has 2 parts. So let's have a look at question 2. Consider the weighted voting system, Q, and then 24, 18, 14, 9, and 4. First question is, what is the smallest value that the quota Q can take? All right. Well, the general rule is this: the quota has to be greater than the total number of votes over 2. That is so that you don't get ties and you don't get really strange situations like how something would seem to pass and not pass at the same time or something. So that's the normal rule. Quota bigger than the number of votes over 2. The number of votes, same kind of thing as last time. We're going to add these up. 24 plus 18 plus 14 plus 9 plus 4. In this case, what we're going to get is n equals 69. Right? So that gives us that the quota is going to have to be greater than 69 over 2, right? Which 69 over 2 is 34.5. Okay, so that gives us an answer. Next whole number up, quota in this one, 35. All right, so that was all A for this one. B. What's the largest value the quota can take? Well, generally speaking, the largest value is the total number of votes. This is kind of unusual, maybe even really unusual, but it can be that big. It just doesn't make any sense to be bigger, right? If we only had 69 votes, like in this case, if the quota was 70, no motion could be passed, right? No rules could be changed, nothing. So the max is n, and even in this situation, so in our situation here, we've got a quota, the max is going to be 69. If we set it at 69, that means we're going to have a completely unanimous vote to pass a motion or to change anything. All right, so that's kind of unusual, but there are situations where organizations make that kind of choice. All right, last question here. Consider the weighted voting system Q 15, 14, 7, 5, 4. All right, find the smallest value of Q for which A, all 5 players have veto power. All right, so part A here. Well, let's look at the smallest. So we have 1, 2, 3, 4, 5 voters. So the 5th voter here is usually what you do, they call them players, is so we'd call them P5 is the normal notation. Player 5 has 4 votes. All right, that's the weakest voter. So if this guy has veto power, everybody has veto power. Well, what's it going to take to get this guy veto power? Well, the easy way to, first we're going to have to do is get the total number of votes again. So I'm going to add them up, 15, 14, 7, 5, 4. I'm going to find that n equals 45. Okay? So then the simple way to find, the simplest way I know of anyway to find veto power for 45 is just to subtract. So 45 minus the number of votes that player 5 has is 41. Okay. Now you notice what happens here. If you set the quota at 41, P5 does not have a veto because there's all the other players, right? 45 votes total minus P5's votes is 41. So the other players added up, the other 4 players, P1 through P4, if you add them up, they have 41 votes. So they could pass a motion, no matter, even if P5 opposed it. P5 does not have veto power. So what you're going to say then is that the quota needs to be bigger than 41 for P5 to have veto power. Okay, well, the next number up from 41 is 42. All right, so there's the smallest quota for which P5 has veto power, part B. P3 has veto power, but P4 does not. All right, so P3 has veto power. Well, if you look here, P3 is this one, has 7 votes, all right? So P3 has 7 votes. All right, so 45 minus 7 equals 38. Okay, so to give P3 veto power, we're going to need a number bigger than 38. So, all right, so that's the first part of what we need. We need P3 to have big veto power, we need bigger than 38. All right, well, the next thing, though, we want P4 does not have veto power. All right, and P4 is this one here, has 5 votes. So P4 has 5 votes. So 45 minus 5 is 40. Now remember, that's the biggest number at which P5 does not have veto power, right? And we want P5 to not have veto power. So 40 there, so that's going to tell us Q, or the quota's got to be less than or equal to 40. All right, so these are 2 criteria. P3 does have veto power, you need a number less than 38. P4 does not, you need a number, you need a number greater than 38 to give P3 veto power. You need a number less than or equal to 40 to make sure P4 does not, and you put those 2 together, and what numbers fall in are greater than or equal to 40? Less than or equal to 40 and greater than 38? Well, 39 and 40. Q is either one of those. We meet the criteria. P3 has veto power, but P4 does not. That's it for our first video of this series.